In this tutorial, you will design and build your own Arduino Shield board. Once you finish this tutorial, you will know all the essential steps to design and build any board you like. Let's start. You don't have to install anything. We will design our board directly in browser using software called EasyEDA. Search for EasyEDA. Go on EasyEDA website, pricing, and we are going to use this free forever standard edition. Click here, open standard edition. You need to register and log in. It's free. And we are going to start new project. I'm going to call it Arduino Shield Tutorial. Save. Okay. And I'm going to rename this schematic. I'm just going to call it schematic. Okay. Now click here. I'm going to change the size of our schematic, make it a little bit bigger, and I'm going to change the title to Arduino Shield Tutorial. And also I'm going to change the company name to Fedevel. Save. We are going to add title on our schematic. Again, I'm going to call it Arduino Shield Tutorial. Change the color. You can use same color what I'm going to use, 660000. And I'm going to make it a little bit bigger. And maybe use bold. Okay. Now search for Arduino dimensions. Go to images. And maybe use this. Open it. Scroll down. Open this drawing. And save it. Search for Arduino Uno pinout. Again, go to images, open this one, scroll down, open this PDF. I'm going to close this. I'm going to take screenshot of this. So we can use this picture directly in our schematic. Save as Arduino pinout. Save. Okay, close this. Go back to our schematic. File, import image. First, I'm going to import the dimensions. Select it, and you can use same location and same size what I'm using. So your schematic looks same as the schematic what I'm creating. Okay. File, import image, and also import the Arduino pinout. If you like, you can just drag it like this, but if you use exactly same numbers what I'm using, then your schematic will be exactly as what I'm creating. Almost done. Okay. Save it. And we are going to add the headers. So search for buy Arduino headers. Let's see what we can find. Maybe open this Spark Fan. And I like this. This is what we are going to use. So go to Documents, Drawing. Okay, we can close this. And this is the header what we would like to fit in our Arduino. So we need to add the headers into our schematic. Go to library, search for header, through hole, 10 pins, pitch 2.54 millimeter vertical, male. And we don't have to find exactly the headers what we are going to fit. Maybe search for like Molex headers. Not this one, this is too raw. Maybe like this one. Okay, we can use this, place it. So this is not exactly what we are going to fit, but it's good enough. It's very quick way how we can add these headers into our schematic. Flip it. Pin number 10 is on the top, pin number 1 is on the bottom. And place it maybe here. Watch my cursor position. Okay, perfect. Copy the manufacturer part number, go to libraries, paste it here, and we need 8 pin header. So I'm just going to change this to 08, search, select it, and place it. Okay, so this is going to be our 8 pin header. Again, this is Molex header. It's not exactly what we are going to fit, but this is like very quick way how we can add these headers into our schematic. They don't need to be exactly what we are going to use, because you can basically fit there any kind of through hole header with 2.54 millimeter pitch. Okay, copy the manufacturer part number. We need to place, okay, it's already here. I'm going to change this to 6. So we are going to place the last header, 6 pin header, select it and place it. And these are all 4 headers what we need. Now let's have a look where pin 1 should be located on these headers. So search for Arduino Uno and scroll down. We would like to find schematic. Here it is. Open this and let's have a look on this power header. Pin 8 is where V in is located. So this is the power header, this is V in, this should be pin 8. Okay, so we need to flip this. Pin 8 is V in. Okay, and move it maybe like here. Again, watch the mouse position. And I'm going to name it J1. Next header is this one. So go back to schematic, find it. This is the header, and AD0 is on pin 1. So AD0 is on pin 1, okay? So we don't need to do anything with this one. Pin 1 is in right position. I'm going to rename this to J2. The next header is this one. D0 is on the bottom. D0 should be on pin 1, okay? So pin 1 is there, okay? So this one is correct. I'm going to just name it J3. And let's check. This is the 8. The 8 is on pin 1. So here is pin 1. Okay, this is correct. And I'm going to just rename this to J4. Maybe make it a little bit nicer. Move this. Okay. Okay. Save it. Now design, convert schematic to PCB. Just click here, apply. Go to 3D, and we need to place these headers on our board. So first we need to create the board. Save this. I'm going to delete the original board outline because we are going to completely redraw it. Change units to mils, snap size 100 mils. Open the dimensions of the Arduino, go on board outline layer, make it active, and start drawing. So this is the 0, 0 position. Watch where mouse X and Y is. Okay. 2600, then 100, 200. Watch these dimensions. Okay. That's what I'm doing. That's where I click. 1490. Okay. 1590. Watch the mouse X and Y positions. Okay. Okay. Left. Oh, okay. I changed snap size. Left click, and right click. Perfect. J1, J2, J3, J4, and we need to rotate them or double check the pin 1 position. Okay, pin 1, pin 1. Oh, we need to rotate this. Okay, this one, just press spacebar to rotate it. Okay, now we are going to place it into correct position. So this one is 1100 and 100. I'm going to move it. Watch the in one position. Okay, see? Move also J2, again 2100. J3. I'm going to move it here. And this one is 1640. So I'm going to change snap size to 10 mils and just move it. Okay. I'm going to add mounting holes. So just select it. Change the number to 1. It's not really like important, but it's nice to have it like 1. And I'm going to change the dimension to 125 mils, and the hole size is going to be also 125 mils. Position is 550, 100, and this is the mounting hole what we are going to use. Copy it, select it in the middle, right click, paste, and place the next one here. Okay, I'm going to change the snap size so it's a little bit easier to place it. Again, right click, paste, put it like here, and the last one, right click, paste, and here. Perfect. Save. Double check what hole size we need. So this one is you can see 1.1, and part size is 1.7. This one is 1.5 and 1. This one is 1.5 and 1. 1.9. Okay, let's make them all same, like 1.7 and 1.1. So I'm going to select all these pins, and I'm going to change the hole size and the part size to have them all the same. 1.7 and 1.1. Okay, and also check this one, 1.575 and 1.7. So select all these, put here 1.575, 1.7, and hole size 1.1. Now all the paths have exactly same hole size and same path size. I'm going to select these mounting holes, and temporarily I change the hole size because we would like to print this. File, export PDF. Be sure size is 1:1. Check all these, export. We are going to print this PDF, open it. Be sure when you are printing this PDF, I'm going to change this to A4 because that's what I'm using, but be sure the size is actual size and print it. This is how it looks. And put it on the Arduino, okay? Be sure position of the mounting holes and the connectors is okay. Don't forget to put the hole size back, and this is how our board looks in 3D. Maybe what we would like to do, we would like to place the headers on the bottom, so 3D model looks a little bit better. So I'm going to select these headers, place them on the bottom. Be sure you put the pin 1 again to the right location, because when you place it on the bottom, the header will rotate. So place it on the bottom and again rotate back to correct pin 1 location. Now double check the 3D model. Okay, this is something what looks like Arduino shield. We have these basics. And before you continue, be sure the mounting hole position and be sure the header positions are correct, because if they are not correct, everything what you will do from now, if they are not correct, you will have to redo it. Okay, so be sure headers and mounting holes are in the correct position before you start doing next steps. So first we are going to place the nets. This one is not connected, so I just put there this not connected marker, and I'm going to connect this pin number 2. Just draw this wire, draw this connection, and I'm going to connect it to power. Let's have a look. It's I or F, so I'm going to call this plus I or F. Turn off the snap so we can freely move and make it nicer. Put it back. This is very important. Always when you disable snapping, then enable it again. And connect pin number 3. This one is going to be reset. So I'm going to put there this net label, and I'm going to call it reset. Basically, this will name the net. Okay. Connect pin number 4. Again, this is going to be power. And I'm going to call it plus 3v3. Make it nicer. So disable snapping, move it, and enable snapping again. Very important. Don't forget to enable it again. Next one, plus 5 volt. So connect pin number 5 to power, plus 5V. Make it a little bit nicer. Okay. Pin number 6 is ground, also pin number 7. So draw this short connection and place this ground symbol. And the last one is V in. So connect this to plus V in. Make it nicer. Okay. Perfect. Next header. These are I2C inputs. So draw a wire, copy it, and place it. Copy, paste, copy all three, paste all three. Now we are going to place these net labels, change the name to A0, and now do it like this. It will automatically increment the number. Okay. Now when we have a look into schematic, AD4 is also SDA, so I'm going to update the name A4 SDA, and I'm going to also update this one. A5 is also clock, I2C clock. Okay, now next, these are data pins. So again, I'm going to draw a wire. I'm going to copy it, paste, copy all three, and paste them because it's faster. We can delete this one. Connect also these. Okay. I'm going to connect this to ground. Pin number 8 is reference voltage for analog inputs. So let's call it a ref. Make it nicer. And these pins, we already connected them because as you can see from this schematic, they are exactly same pins as on the other header. So we are not really going to connect them here in the schematic. I'm going to use this do not connect mark because we really don't need to connect them on the shield. They are already connected on the Arduino itself. I'm going to name this D0, and automatically we are going to place also D1, D2, and all these other nets. This is quick. Super helpful when it increments automatically. And I'm going to also check this D0. It is also RX from the serial port. So I'm going to put here /RX, and D1 is TX. So I'm going to put here TX. Okay. This one is also chip select for SPI bus. This one is MOSI. This one is also MISO, master in, slave out. And this one is clock. Okay, double checking schematic. Okay. Perfect. And that's it. We named all the nets connected to our headers. I'm going to make it a little bit nicer. Notice when I selected like this, everything what is touching the selection will be selected. But when I select it like this, only what is inside of the selection will be selected. I'm going to also put some nodes to this pin 10 and pin 9, so we know on the Arduino it is actually clock. So I'm going to call this A5 clock. I'm going to make it a little bit nicer, smaller, maybe like this. And it's on pin number 10. So I put it here. And also I will make a note about pin number 9. So these are not really connections, but this is just to remind us that this pin 9 and 10, there are actually these A5 and A4 connections in case we would need them. Save it. Now I'm going to make our schematic nicer, so I'm going to use this title and I'm going to call these headers. Copy this and I'm going to call it our circuit. So this is the place where our circuit will be. And very first thing what we are going to place is power LED. Search for LED green 0805. Let's use this one. Click on place and left click to place it into our schematic. To use LED, we also need a resistor. So search for 560R 0805. So this resistor is limiting the current which is flowing through the LED. Use basic part like this one. Click on place and place it into our schematic. You can use exactly same components what I'm using, so double check the numbers. I'm going to connect it to 3.3 volts and to ground. Okay, use this wire connection and this is the power LED. Copy this. I'm going to put a title and change it to power LED. Maybe make it a little bit different from the big header. Maybe like this. Perfect. Okay, so we have our very first custom circuit on our Arduino shield. Search for servo pinout. Servo is something else what we are going to add on our board. Notice all the servos, they have like same connector, this 3-pin connector. So we need to place a 3-pin header on our board. Again, we are going to do it very similar way as we did for all the other headers. So I'm just going to copy and paste here this Molex part number, change it to 3-pin and place it into our schematic. Also search for 100 nanofarad 0805 Samsung. And use this basic part in on place. So this is something what you may want to place close to these headers, which are going to power servos. And we are going to connect it. So pin number 1 is connected to ground. This is super simple. I just copy and paste it here, the ground symbol. Pin number 2 is connected to power and also to our capacitor. This capacitor in the final board, you can actually use different values of the capacitors, or you can put there some, instead of this 100 nanofarad capacitor, you can put there some protection circuits. Depends on what kind of servo or what kind of circuit you will be connecting to this header, because it's kind of universal header. You don't need to connect there only servo. I'm going to connect it to header power. So we will actually create special power which is going to be used to power these servos. You really don't want to use the 5-volt Arduino to power motors or servos because they can damage the Arduino board. You would like to use separate power. And we need to connect the control pin of the servo to our Arduino, and I'm going to use pin number 4. It's this one. I'm going to copy this net label and I'm going to paste it here. Okay, it's so simple. This is how you basically connect or place header for servo. I'm going to move it here, and we would like to support 2 servos. So what I'm going to do, I'm going to actually copy this circuit and I'm going to paste it. I'm going to call this servo 2. And what do we need to do? We just need to change this control pin. So instead of D4, or which one we could use? We don't want to use D5 and D6, they are PWM supported. So I'm going to copy this D7 and put it here. Next, we are going to add support for this power, which is on headers. So first, I'm going to add a simple header, which we will use to select the power between external power and 5-volt voltage coming from the Arduino. So search for header through-hole 3-pin pitch 2.54 vertical male. Maybe this one, not this one. You would like to use something with very short pins. So we only need it for jumper. We don't really need a header with long pins. So use this one. This one looks like it has short pins. We can double check the data sheet. So I'm going to check what is the length of the pins on the Molex headers, which are on the servo. It is 7.48. And let's have a look if this one is shorter. I think we need around 5-6 millimeters. That's enough for jumpers. Its mating length, and it's 103. 103. Okay, it is 5.8. Oh, okay, between 5 to 6 millimeters. That's exactly what we need. This one is much longer, 7.48. That's why we didn't use the Molex model or Molex header, because on the model, 3D model of the Arduino, we would like to have this one a little bit shorter. You will see when we finish the board. I'm going to call this power selection. And as I said, this is going to be used together with a jumper or link. So I'm going to place this header power on the middle pin, or I'm going to connect it on to the middle pin. And then pin 1, I'm going to connect to 5 volts. And pin 3, I'm going to connect to the external voltage. Okay, so I'm going to call this plus Vx. You really don't want to connect motors or servos to plus 5 volt, but maybe in some applications you can use 5 volt. If you use motors and connect them to the Arduino power, you can damage your Arduino. Okay, perfect. Then use jumper between 1, 2 or 2, 3 to select the power for the servos. Go to Farnell or DigiKey or anything what you use, and we would like to also find the jumper or a link, so we don't forget to buy it when we will be ordering components to build our board. I'm going to just search for jumper, maybe like this, jumpers and shots. Okay, I'm going to filter based on the pitch, and I would like to use this red one. Okay, this is what we can use to connect the pins 1, 2 or 2, 3. I'm just going to make a note down here. I'm going to change color and also size, maybe like this, and I'm going to put here the note about the jumper. Use a jumper. This one to select power for headers. Okay, don't forget, you need to fit the jumper, otherwise there will be no power on the servo headers. We are going to connect a capacitor to this header power. Search for 100 microfarad. Click on these tantalum capacitors. Maybe use this one. Apply. Let's have a look what they have in stock. And maybe we could put there this one. 6.3 volt, 100 microfarad capacitor, case B. Copy this LCSC part number. And here paste the part number and search for it. This is the capacitor, select it and place it. If you are not sure why I'm putting here this capacitor, don't worry, okay? We are not going to fit it, we are not really going to use it, but it's good to have this footprint on the board in case you need to fit there something, in case you need to fit there big capacitor or some other components, protection or something. Be sure if you fit here something, it has to meet requirements for the external voltage. As I say, we are not going to fit this 100 microfarad. So I'm going to put here a note like NF, not fitted. We are going to connect this external voltage. Search for Molex 2-pin polarity header. This is a special header. For power, you really would like to use the headers which can prevent the reverse polarity connection. Okay, there is only one way how you can connect this header. That's very important. So I'm going to copy this part number. I'm going to search for it. Let's see if it's in the library. And place it into our schematic. This is exactly the header what we would like to use. Okay, so because this is special header, there is no way you can connect the power the wrong way. You will always only connect it the right way. So I'm going to connect pin number 2 to ground. And as usual for the power pin, we would like to also use capacitor or this capacitor, which in case you need, you can change the values of this capacitor, or you can even use their different kind of component, protection component or anything what you will need. Okay, I'm going to connect this header to the external voltage. Make it a little bit nicer and put here description. External power. Okay. Perfect. For this header, we also need mating. So I'm going to search for this Molex header. And let's have a look what is the mating, what are the mating parts. It's this one. So this is something what we will need to have on the cable which will be connected to this header, and we would like to use this one. Okay. So this is going to prevent the wrong insertion. This will help us to only connect the power one way, and also we will need these screens. So I'm going to search for what we could use. I like the gold ones, so maybe we could use these. Okay. Again, when you will be buying components for this board, you would like to order also this mating part and these crimps, so you can make the cable which you can connect to this header. I'm going to place a note here, a connector to use external power for servos and MOSFET header. Housing is this one. I like to put this information into schematic so we don't have to search for this again later. And crimps are these. Okay. And now you can guess what we are going to connect next. MOSFET. So search for Arduino MOSFET connection. What can we find here? Click here. Open it. So we would like to use maybe this kind of transistor. Turn loads on and off with your Arduino. And here is the schematic. And this is what we need. So I'm going to copy information about this transistor, search for the transistor in our libraries. Or maybe not this one, this is not what we would like to use. This is what we would like to use, this kind of true hole transistor. Place it into our schematic. Okay. Now we also need a header and special header. I'm going to search for female headers. Use this one, 2.54, 2 positions, 1 row, and we could use this one. Okay, so these are not really pins, but this is the female header. So there are the holes. I'm going to find it and place it into our schematic. Okay. maybe flip it. And this is not everything what we need. We need to put there more components. This diode. Search for this one, okay? This is a standard diode which you can use in this kind of circuit. It is to protect the circuit. I'm going to place it like this. And also, as usual, we would like to put here the capacitor. Again, you can put there different capacitor values or different components in case you need. And also search for 0805 resistor, basic part, this one, which we will use to specify the level of this switch, initial level of the switch before the firmware or the software inside of the Arduino will work. And we would like to also put here 0 ohm resistor. I'm going to just change this part number to 0. Again, this is a component maybe what we don't really need right now, but you can use it to experiment in case you need it. In some cases, maybe you would like to change it. I'm going to connect everything together. That's super easy. Do it like this. I'm going to copy this and paste it here. And also here, maybe move it a little bit. Okay. For power, we are going to use this header power. And this switch is going to be controlled by a GPIO. And for this one, we would like to use PWM GPIO, for example, this D6. So I'm going to copy and paste in here. Okay, so D6 has support for PWM. And this is a very important net, so I'm going to name it like SW. So when we will be doing layout, we know this is important net. I'm going to copy the title of this small sub-circuit. I'm going to call it MOSFET header. And this one is done. Save everything. Now, don't forget, you can replace this resistor if needed. This one is used to switch off this switch when the firmware is still not initialized. This diode is protecting. It's all connected to D6, which supports PWM. Now, we would like to put there also user LED, something what we can control by firmware. So I'm going to simply just search for red LED. We would like to use different color than what is the power LED. Maybe what we could use. I don't know. Use this one, for example. It's not really important which of these LEDs we will use. Important is the footprint is 0805 and symbol looks nice. We also need the resistor. In case you would be actually ordering assembly service from JLC PCB, then it would be important what kind of components you select. But because we will be fitting all the components by ourselves and we will be ordering the components by ourselves, it's not really important what component exactly you use here in the schematic. I'm going to connect it to D8. Okay, so this is simple digital pin which we can use to control this user LED. I'm going to copy this and I'm going to call it user LED. We are almost done. There is one more thing what I would like to show you how to connect I2C. So search for Arduino I2C temperature sensor chip, because many people need to connect I2C. So click here, and let's say we would like to connect this sensor. This is SMD component which we can directly place on our board. I'm going to find it in the libraries. Maybe this one. Okay. Place it into our schematic. So how do you connect this? It's super simple. If you have I2C device, first maybe double check the datasheet and double check the input voltage, and also what is the recommendation. In this case, for this sensor, no external components for operation except for pull-up resistor on SCL, SDA, and alert is required, plus 100 nanofarad decoupling capacitor. So I'm going to copy this resistor. These are 10K resistors which we can use as pull-ups on the SDA, SCL, and alert. And I'm going to also copy this 100 nanofarad capacitor which we will use on the power. So this is going to be the decoupling capacitor which is recommended in the datasheet. I'm going to connect everything. This one is connected to alert, SCL, SDA, and we can connect all these to power. We can use this 5 volts. Okay, don't forget, always double check what is the required power voltage for your chip. This one supports 5 volts, so it's okay. I'm going to copy the net name of this SDA signal. Be sure it's connected correctly. And I'm going to connect this SCL. And again, be sure it's correctly connected. SCL, SCL, okay? We would like to connect alert to an interrupt pin. So we can use, for example, this one, interrupt 0, or it is IO pin 2. So I'm going to copy this and we can connect it here. Okay, so if there is like very high temperature, we would like to call an interrupt in our microcontroller and maybe turn on fan or something. Connect the rest of the pins. So these A0, 1, and 2, they specify the address of this sensor. We can simply connect them to ground because it's very simple connection. And then this is useful if you have like more sensors, so you would like to place each sensor on different address so you can communicate with them, but in this case we only have one sensor, so we can simply connect everything A0, A1, and A2 to ground. I'm going to make it a little bit nicer, maybe like this. And copy the title and call it temperature sensor. I'm going to add a note. So you remember that this chip is compatible with LM75. In case you need some firmware or software, you can just search for LM75. Save everything. And now we need to annotate our schematic. Remember J1, J2, J3, J4. when we annotate schematic, we are going to change this. So notice what is going to happen when I reset it. Everything is now with question mark, H question mark, R question mark, everything is with question mark. We would like to keep these names J1, so manually I'm going to put the names back, but only for these for the headers J1, J2, J3, J4, and also for these other headers. This one is going to be J5, J6, J7, J8, J9, and all the other components I'm going to annotate automatically. So again, notice right now there are just question marks. If I go here and select keep existing annotations, annotate, watch what is going to happen. Okay, all the other components now they have these numbers C1, C3, R1, LED1. Maybe annotate the schematic, your schematic exactly same names as I have them in my schematic. It may be helpful for PCB layout. Okay, now we would like to check our schematic. So before we import everything into our PCB, we would like to double check how everything is connected, and here are some errors. But this is fine because we know all these nets, they are only connected to one pin. This is all fine. Go through all these errors, they're all fine. And now double check all the other connections. So this is the 3.3 volt, 5 volt. Okay, everything seems to be connected correctly. Okay, this is connected correctly. So we do have some warnings or errors in our schematic, but it's only because some of our nets are connected only to one pin, but we know it's fine because we went through all these connections. So even if there are errors, we can import our schematic into our PCB. Okay, so design, import changes. We know there are errors, so just ignore them and apply the changes. Okay, so these are all the components what we need to place on our PCB. Save. Change the snap size to 10 mils. Now go to our schematic and we are going to place the power LED. Select it, tools, cross probe and place. Now we are holding the LED, left click, right click. Watch where I'm going to place this LED. It will help you with placement and routing if you place the components exactly into same position as I will. Select the resistor. Again, place it. Don't forget, left click, right click. Now watch where the pins are connected or which pins are connected together. You can see it based on these blue wires and place the resistor. Next, we are going to place this header. The header which is going to be used for power selection. Press spacebar to rotate. And again, watch the position. Next, the external power input header. Press spacebar to rotate and left click. Now we would like to hide these reference designators. So just hide it like this. And it's because it's easier, it's more clear when you work with the PCB. Place this capacitor which needs to be close to this external power input. place it like this, and place also the second capacitor, which needs to be close to the header for the power selection. Watch how the nets are connected and think about the layout, how you are going to connect these pins when you will be doing the layout. Okay, you can connect all these on one layer. That's perfect. That's exactly what we would like to do. Placement is very important. Now we are going to place this temperature sensor. Again, watch what could be the best position for this chip. Maybe like here. And we need to place there also these pull-up resistors. This is the first one. Think about how you are going to connect it. So we are going to place it here. The second one we are going to place close to the first one. Press spacebar to rotate like this. And also place the last pull-up resistor selected in the schematic, tools, cross probe and place, left click, right click, and left click. See how is it going to be connected? Like this. When you hover a cursor over the pad, you can see where they are connected. Now this decoupling capacitor, it needs to be close to the power. So I'm going to place it here. Okay. Save. Now this servo 1 header, where is it connected? Okay, there. So I'm going to place it somewhere here. Watch the position. Okay. Then the capacitor close to this connector. Maybe like this. Next, we are going to place the second servo header. Okay, it's going to be connected there. So we can place it here. You can guess what we are going to place next. The capacitor. Place it close to the header. Now, the MOSFET header. Maybe like this. I placed all of them in one row, so it looks nice. Capacitor. Spacebar to rotate. The protection diode. Watch how the pins are connected, so you rotate the component correctly. And now this transistor, I know which one it is. We don't have to go always to the schematic if you know which component is which. Okay. Only few components left. So let's place this 10K resistor close to our MOSFET. 0 ohm resistor. Okay. And the user LED, select the LED. It's connected to this header, so I'm going to place it close to the header, somewhere here. And also we need to place there the 560 ohm resistor. And that's it. All the components are placed. Let's have a look on our PCB. Awesome, this looks really cool. Super quick and super simple. Save. Go to Tools, Layer Manager, double check if you are using two-layer PCB. Now go to Design Rules, and we would like to set up the rules before we start doing layout. So search for JLC PCB capabilities. Always when you are doing PCB layout, check the capabilities of your PCB manufacturer. We would like to check this minimum via hole size and minimum via diameter. So drill diameter for via minimum is for double layer PCB 0.3 millimeter. 0.3 millimeter, that's 12 mils, and we are using 12 mils, so that's good. They will be able to manufacture it. And minimum via diameter for double layer PCB is 0.5 millimeter. We are using 24 mils, so let's have a look. 24 mils is 0.6 millimeter, so we are using like much bigger path than what they can manufacture, so this is good. Now minimum track width, what JLC PCB can manufacture is for two-layer PCB 5 mils, and we are using 10 mils, so they can manufacture it. And minimum clearance is again 5 mils, but we are going to use 10 mils, so I'm going to change this. If you would like to learn more about how to set up correct rules, how to decide on PCB stack up, or how to decide on layers, or how to route tracks, check out our online courses. We have courses in different software in KiCad, Altium, Cadence. We have courses for beginners, for professionals about hardware design, PCB layout, EMC, measuring, and more. Just go to fedevel.com. You may find there something interesting for you. Now, let's go back to our board and let's continue. And now we can start doing layout. So we are going to connect these pins together, go on top layer, make it active, and just left click. That's it. That's how you route the PCB. Left click. You can use spacebar to change the way how the suggestion is made. So when you will be doing layout, when you will be routing, try spacebar. You will see what will happen. I'm going to change the, or be sure the snap size is like 10 mils, otherwise routing may be difficult. And if it's too difficult, you can make it smaller, but 10 mils makes nice PCB. Let's connect the alert. So do it this way. See, when you are doing placement, always think how you are going to connect the pins. Ideally, you would like to connect them on one layer, if it's possible. That's what we are doing here, because the second layer will be ground on this PCB. So ideally, we would like to be able to connect or make all the connections on the top layer. Okay, I'll let this connected. I went around this hole because don't forget, if there are some screws or something, you really don't want the screw head damage the track. So I went around the hole. I'm going to connect the ground, maybe use a little bit wider track for powers and grounds, like this, 20 mils. Left click and place a via here. So via will make connection from top layer to the bottom layer. And as I said, on the bottom layer, we would like to then place the ground plane. We will do it a little bit later. First, place the ground connections also on these other pins. Place the vias. Be sure the vias are connected to ground. You can see the text there. Now let's make the ground plane. So go on the bottom layer, use this copper area, select ground net, because we would like to have this plane connected to ground, and just draw around the board outline. Left click, left click, left click, left click, left, 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 right when you would like to finish. Okay. Now select this polygon or plane what we created. Just hover cursor over the edge like this, left click. And here are some parameters what you may want to change later. Sometimes you may want to rebuild the polygon if you make some changes. Okay, let's go back on the top layer and let's continue connecting the other pins. So we are going to connect this power. Again, use 20 mils because it's power. We would like to make it a little bit wider. Also connect this to 5 volts. Draw it maybe like this. Okay, when you draw it exactly same way as I draw it, it will be easier for you to do the layout. But if you like, you can do it your own way. It's perfectly fine. Okay, I will connect it to the 5 volts coming from the header. Next, we can connect this to ground. All the connections to ground are very simple. It's just this short connection and ground via to the bottom. Okay. I will maybe make this a little bit different. Just press left button, hold it down and move it. Next, connect this D4. I'm going to use 10 mils again. Connect it. Also connect the second servo, maybe like this. Okay, again, hold and move mouse. Zoom in, zoom out, use mouse wheel. If you would like to pan PCB, then just press right button, hold it down, and you can just move the PCB. You can try it. You will see what it does. This one is going to be a little bit tricky because it's crossing the track what we already have there. So I'm going to go on the bottom layer with this track, like use a via, go on the bottom, and just draw a very short track like this. We really don't want to break the ground plane on the bottom. Place a via here. We need to rebuild the plane on the bottom, so just select it and rebuild. Okay, so here is our very short track on the bottom layer and continue on the top. This is the simple way how you can cross the tracks on your PCB. Notice I made this track a little bit wider. For this PCB, it's not really like super important what kind of track width we will use, but I wanted to use different track widths just to point out that in some boards or some designs, you may want to use controlled impedance, and very often for digital tracks, you would like to use like 50 ohms. But for two-layer PCBs, it's difficult to route with 50 ohms, so I just use these 10 mil and 20 mil white tracks. 10 mils for like standard signals, 20 mils for powers and grounds, and for the PWM signal, which is controlling the MOSFET. Okay, connect the power for headers, and also we can connect this MOSFET. Notice I keep using the spacebar to change these suggestions, how the software is suggesting the track layout. Again, spacebar, left click, spacebar, left click, Okay. Right now we are just trying to connect everything, just to be sure we will be able to do it. And then a little bit later we will maybe make some adjustments and make the layout a little bit nicer if it's needed. And we will also draw power planes. So these powers, what we are drawing right now, sometimes maybe instead of using tracks, you would like to use power planes. You will see, we will do it later. So this is 3.3 volts. Make it a little bit nicer. Okay, connect this and connect the LED to ground. Use a via. For the via, don't forget, use the standard size 24, 12, okay? 24, the pad size, 12 is the drill diameter. It should be set by default this way, but if it's not, you can just click on the via and double check the parameters of the via. Okay, and connect this. Go around. And connect these to plus 5 volts. It's almost done. You can see there is one connection which is missing. I just will adjust this. Okay, maybe here. Okay. So there is this one connection missing. I'm going to connect this, but I will leave the other one unconnected because I would like to show you how the errors will look. So once you connect everything, you can save your board and then go to design, check DRC. And if there is something wrong, you will see it. See, there is one error, and when you select it, you can see there is one unfinished or incomplete net. It will also tell you where exactly it is. This is super helpful. You always should run this DRC rule check when you finish your layout. And now I'm not going to draw a track. I'm going to actually draw this plane, select it. And this is important. Change the path connection to direct. Okay, now place here some vias. You can see they didn't pick up the ground net, so I'm going to just manually write it here. Also, I will put it here and here. We are going to draw these power planes for other powers. But first, let's double check if we fixed everything. Okay, save this. There are no errors. We are going to improve the layout. So we are going to use Polygon for this ground connection, which is here. Just go around these through hole pins and around this path. Then select the polygon. Use direct connection. Okay. Next, this external power again. We would like to use this copper area. Select the net. Draw around the pins and create this copper area. This will take a little bit of time, but it's for practicing, yeah? So you know how to do it. If you would like to adjust the polygon, you can just, drag these points and then don't forget to rebuild the polygon. Okay, next we can make this a little bit bigger here, plus 5 volts. And I'm going to draw this copper area around this pin. maybe a little bit up. Okay. And just connect it. Left click, right click. Select the edge and change to direct. Now the big polygon. So we are going to draw this copper area for powers or headers. I'm trying to make it nice. So I watch the corners. I would like to have everything aligned nicely with the pins and with the paths. So I just draw it like this. Now you can practice how to draw polygons. This is the biggest one. So just play with it. Make it nice. Maybe like this. Go down around this big capacitor, which is not fitted, but can be used in case you need it. I'm going to change the snap size to 5 mils. Okay, maybe like this. And let's go back to 10. I use 10 mils very often because you can very nicely and easily align everything again, so it looks nice. If you use smaller snap size, then it may be more difficult to align the tracks or these edges of the polygons. And almost finished. Let's go up here. Left click, right click. Select. Change the path connection to direct. And adjust if it's needed. Okay, it looks good. Maybe I'm going to move it a little bit because the space between the power and the tracks is small. We can make it a little bit bigger, so I'm going to move it like this. Because the power can be quite noisy and the other track is interrupt. We really don't want this noise to be picked up by the interrupt track, so I moved it away. Now this switch, there may be quite high currents flowing through these tracks, so we would like to make it wider. And we always use this direct connection on the top layer because it's not really necessary to use different kind of thermal relief on the top layer. But if you use like ground connection, as you can see, there is ground connection. It's using thermal relief, so there is no direct connection. And it's because then it's easier to solder these pins. But this polygon is quite small, so we can use this direct connection. Okay, now we are going to add some support for this MOSFET. We would like to create some heatsink or a heatsink area on our PCB. I'm going to open datasheet of this MOSFET. We would like to see the mechanical dimensions. First, there is this hole. Size is 3.5 millimeter. So we will need this hole on our PCB. I'm going to use this path. I'm going to double check 3.5 millimeter. We would like to maybe use smaller hole, 3.2, so around 125 mils. I'm going to change the hole here, 125 mils, and also size is going to be 125 mils. Now we need to find out where to place it. It's going to be placed in the middle, but distance from the path is going to be, I don't know, this is 4, this is 2.8, 15.2, don't know, let's say 18 millimeters, 700 mils. So right now this is 1800, so I just move the hole to 1100, 700 mils to the left. Okay, I updated the polygon on the bottom. But we need to make bigger hole, or bigger, we need to make some clearance around this, because you can see it's connected to drain. This heatsink is connected to drain. And drain is connected in our schematic to power, basically, to this switch node, not to the ground. And we would make the short circuit if we put there a screw or something. So we need to make some clearance around the hole. Let's check how big clearance we need. So there is going to be M3 screw, and we would like to know what is the size of the head. That's the A, and for M3 it's like 190 mils. So what I'm going to do, I'm going to place circle on bottom layer, and I'm going to make the radius is radius, okay? This is diameter to 190, that's diameter. So I'm going to make this radius like 200. So there is a lot of space around the head of the screw, okay? So the head of the screw can easily fit into this empty space. I'm going to change this to pin number 1, so it looks nicer. Okay, let's go back on the top and save this. What we would like to do next, we would like to put here some copper area. So I'm going to change snap size to 50 mils. I'm going to draw solid region. Watch where I'm going to draw it, okay? Draw it exactly same way into exactly same positions. Draw it like this. Okay. Change the snap size back. Select it, copy. Watch the position of my cursor and hold this selection here. Now when you paste it exactly into middle of the hole and delete this. Now we have this copper area, it's quite close to this track. I'm going to adjust this. Okay, so this copper area is going to be used as extra heatsink. I'm going to redraw this a little bit, make more space. Okay, now we can have a look on 3D model. You can see the area is actually masked. That's not good. We would like to unmask this area. So I'm going to select it, select the shape, and I'm going to paste it, but I'm going to paste it on different layer, on this top solder mask layer. Now when we have a look, you can see on top solder mask there is this object, and if we have a look on the 3D model, you can see now the area is unmasked. Without the mask, the heat dissipation is going to be better. Okay, if you see something what can be improved or made nicer, you can do it. But I'm very happy with this layout. So save it. check DRC. Okay, there are no errors. Perfect. What we can do next, we can add some text. So first double check what is the smallest text what we can use on PCB. 6 mil line width and 40 mil the height. So go on the top seal screen layer. This is where we can place the text. And double check what is the size of the text. We can change this to 6 and height 40. Yeah, 40 mils. That's the smallest text what we can do because that's the smallest text what JLC PCB can manufacture. And use spacebar to rotate. Okay, I'm going to change the text to NC, not connected. This pin is not connected. And copy, paste, hold the copy in the middle of the pin so it's easy to place it. I'm going to copy all 4 so it's a little bit faster. Do it also here and one more time here. Delete this one and this one. Okay, now when we zoom in you can see where these nates are connected or where these pins are connected. So I'm going to put here IRF. This one is reset, 3v3, 5 volts. It's very useful to put this information on seal screen because when someone will be using your board or when you will be using your board, you don't have to keep looking into schematic. You will immediately know what kind of signals are there. A2, A3, and this is A4 slash I2C data, and here is A5 and I2C clock. Okay, let's do same also on these other connectors. So place a text here. I'm going to call it D8. Move it so it looks nice and select it. Hold it in the middle of the pin and paste. Copy all 4. Paste them. Okay, delete this. And almost done. Now we have to rename all these. So this one is going to be D0 RX. We will move them a little bit later. Just put here the correct text. D4, D5, 6, 7, and 9, 10. This is also chip select for SPI. This one is also MOSI. As I said before, master output, slave input. The other one is master input, slave output. That's how you remember it. And this is ground. Notice the thermal relief, how the ground pin is connected on the bottom layer to the polygon. And these are not really connected, but we would like to maybe add the text there because they are connected in the Arduino. So there really are these pins, they're just not connected on our board, but they are connected on the Arduino board. Okay, the last one. make it nicer. So move this. You can use arrow down to move them only in one direction. Okay, make it look nice. That's what will people see on your PCB, how nice it looks, and save it. Okay, now we would like to add maybe some description or around the connectors. This one is servo 1. I'm going to make it maybe a little bit bigger. Change this to 10 and 45. Okay, it looks good. Nice. And also put here pin description. So when you will be connecting the servo header, you know which one is power, which one is ground, and which one is the input pin. Okay, like this. I will move it closer so it doesn't look like text in one line. Okay, maybe like this. Good. Perfect. I'm going to copy this and we can use it also down here. I'm just going to okay, move it a little bit down and change the text to servo 2. Okay. Next one is the power switch, MOSFET header. So copy this, paste it, call it MOSFET, use arrow to move it down, header, move it down, make it look nice. And also we would like to put there information about the pins. So I'm going to copy this, paste it. So plus, minus, and it looks good. Next is the temperature sensor. So again, copy this existing text, paste it where we would like to put it, find nice place, maybe like this, and just change the text, temp sensor. Okay. Again, copy this, paste here. This is the user LED. Okay, looks good. Oh, maybe like this. Okay. And also there is power LED, so copy this, press spacebar to rotate, change this to power LED. Now we would like to put the text around the external power. So this is going to be the header for the external power. I'm going to just call it X and plus minus, so we can see where is the plus and minus pin. and this is the power selection. Again, put here the text so everyone knows what is on your PCB without reading the manual. And we would like to know that if these two pins are selected, then it's going to use external power. And if the jumper is on these other two pins, then plus 5 volt is going to be selected. Okay. External when jumper is here, and 5 volts when jumper is here. Okay, maybe we would like to add also the board name and board version. I'm going to call it YouTube Shield version 1 issue 1. Maybe make it a little bit bigger. Like this. You would like to put maybe copyright and company name on your board. So 2023 Fedevel. You can put there your own name or your company name. And I'm going to make a little bit of advertisement for our online courses. So I'm going to put here online courses. If you would like to learn more about how to do hardware design, then go on our website, which is fedevel.com. Okay. Nice. Super cool. Let's have a look. Wow. I really hope you like your PCB, what you created. This looks really, really very nice. Save our board. Don't forget to run DRC check, so you know there are no errors. And also export your PCB to PDF. We would like to print everything and check all the sizes and dimensions and text. So I'm going to print it. Again, don't forget you would like to print it in the actual size. So I'm going to select A4 and this actual size, print. This is how it looks. Cut it out, put it on real Arduino, double check if it's okay. To build our board, we will need to buy the components. You can use this. If you like, you can try it. I have never tried this, but based on the schematic, you can actually order all the components from this LCSC. Just select the quantity, select LCSC, part number, and here you can order all the components from the schematic. But I'm not going to do that because we would like to use a little bit different components. So what I'm going to do, I go back to schematic and I'm going to this export BOM. Export, close, close. This is the file what was generated. I'm going to open this file what we have generated, and these are all the components from our schematic. If you like, JLC PCB can actually fit all these components. Go here. Very quickly, I'm going to show you where you can find it. When you add the Gerber files, here you can actually use the assembly service. But we are not going to do it. We are going to order all the components. You can use DigiKey, or I'm going to use Farnell because that's cheaper for buying components in Slovakia. So I'm going to use Farnell and I'm going to manually order all the components what we need to build our board. I'm going to put here the part numbers. So the first one is 100 nanofarad capacitor. I'm going to copy this, and let's have a look if Farnell has exactly this 100 nanofarad capacitor. Paste, search for this capacitor. Oh, looks like they have something. So I'm going to click on this one. How many we need? We need 5. So if we would like to build 5 boards, we need like 25 capacitors. So I'm going to add this to the basket. Go back to our spreadsheet. So this one is okay. Next one is 100 microfarad. We are not going to fit this one, so not fit it. And let's search for this diode. Go to Farnell, paste, search. Okay, and this is the diode what we need. We need 5 pieces. Okay. Next one is this header. So it is this special header, female header. Let's search for something in Farnell, connectors and cables, and go here, PCB, I don't know how to say it. And this is something what we would like to maybe use, but it's 12 contacts. So let's use filter. We would like to find 2.54, one row, and let's have a look what they have. Okay, it's still 12 contacts, it's the first one. So I'm going to select 2 contacts only. And okay, so there are different manufacturers. I'm going to use the Multicom Pro, and minimum quantity 50, but it's okay. We have this one. Next, Molex. So let's search for this one in Farnell. Paste. Okay, we can use this for the servo headers, and we need 2 of them, so 10 pieces, 2 of them on one board. Next one, let's try this. Okay, they have it. So this is the header for power selection. Cool. It's quick. Next, Molex. This is going to be simple. Search for this one. Okay, so this one is for the external power. We need 5 pieces. Okay. Now the LED. So just go and find LED products. We just need any simple LED. So I'm going to search here and maybe use filter. Again, Multicom Pro, SMD 0805, green. Let's see what they have. Okay, we would like to use something with lower voltage, like this one, and a bright one. So we can buy this one. We need 5 pieces. Okay. we have this one. Now the red LED, we can use something similar. So I'm going to search for red LED in our filter. And okay, this is very similar to what we have. That's the Multicom Pro. I'm just going to use 5 pieces on our board, or we need 5 pieces for 5 boards. We only need 1 piece per board. Next, the resistor. Let's see if they have exactly this part. So I copied the part number, search for this. They don't have resistors from this manufacturer. So we are simply going to search for resistor. Again, maybe use filter. So cheap SMD resistors. And 560 ohms. 0805. Plus minus 1%. Okay, we can use this one. And minimum quantity is 10 pieces, so I'm going to order these. Okay. Next, 10K resistor. So it's going to be similar. I'm going to just copy this part number and I'm going to change this to 10K. Okay. We can use this one. How many we need? 4. So 20 pieces at least. 8. Okay. And a 0 ohm resistor. I'm going to use this 0 ohm resistor category. And Multicom Pro 0805. Let's have a look what they have. 1.5 amps. This is 2 amps. We can use this one. We need 1 piece. Minimum quantity 10. So let's buy this. Go back. Okay. Now the temperature sensor. I really hope they have it. So copy. Paste. In case they don't have some components, then you still can change your PCB, okay? They have this, but only 2 in stock. It's okay. It's fine. I can buy these 2, and that's enough. Okay. Don't forget, you can change it. If you can buy this specific component, you can still change your schematic and PCB. But I'm going to buy this. Okay. And now these headers. You remember where we would like to, or what kind of headers we would like to buy. We would like to buy these from SparkFun, something like this. But I can't really buy from SparkFun, it's in the US. So I'm going to find this on Amazon in Germany. because if I buy from US, it it has to go through custom. It takes a long time. Shipping is expensive. So I'm going to buy these. This is exactly what we would like to use. You can buy them also separately, but this is like $4 or €4 is like super cheap. If you buy them in Farnell or DigiKey, it may be much more expensive. And let's have a look on this last component from the BOM, bill of material. It is the transistor, and they have it, so 5 pieces, right? Okay, so this is the last component from this list, but you remember our schematic, yeah? We put there few nodes. We also need this jumper for power selection, so I'm going to add this into the list of the components we need to buy. Minimum quantity 100 pieces, but okay, jumper. Yeah, I always need some. And let's also buy this housing and crimps for the external power in there. So search for the housing, buy 5 pieces, and also search for the crimps. We need 2 per 1 header. And also maybe you would like to add few more because sometimes you you may damage these when you will be putting them on cable. So I put here 20. Okay. Don't forget, when you will be buying components or selecting components for this circuit, they will depend on this external voltage. Okay, so anything what is connected to the external voltage needs to be for this specific voltage. Capacitor, diode, transistor, everything, double check what is the maximum voltage for these components. We still need to connect the external power, and very simple way what we can do, we can put their batteries. So I'm going to search for battery holder. Let's have a look what they have. We need 4 AA batteries to have 6 volts as external power. And oh, this is maybe what we need, 4 AA battery holder. So I'm going to buy 1 piece. That's enough for prototypes. Go to basket. And these are all the components what we need to build our board. Okay, so buy all these from Farnell or from DigiKey or from any supplier what you normally use. And don't forget we also need the headers. And also if you would like to test this board, maybe you would like to buy servos. So you can just search for servo 6 volts. And for example, you can buy something like this or something like this. Buy everything so when you build your board, you can test it. We can manufacture our PCB, go to fabrication, PCB Gerber files, check DRC, okay, generate Gerber files. These are the files what we need to manufacture our PCB. So this is the file which was generated. Go to JLC PCB website, instant quote, add Gerber file, and select the file, the zip file what we have just generated. We should see our PCB. Okay, perfect. This looks correct. Now, check what we need to change. PCB thickness is 1.6, that's correct. And maybe I would like to use black color. And also surface finish, ENIC. ENIC is the gold finish. via tinted, it means there will be mask over vias. And okay, so black, you can see. ENIC is expensive. If you would like to something cheaper, you can use this lead-free hassle, but I like ENIC because it will be, there will be this gold on the top of the pads, and we can just order this PCB. So let's do it. Continue. Watch the price. If you like, you can try different shipping methods. There is difference in price, but I'm going to use this one. And okay, continue. Here is a coupon, so I'm going to use this one. $35. That's quite good price with shipping. So let's pay. And it's done. Okay, so now we have to wait. I have the PCBs. This is how it looks. These are the components. All of them. Now, put some flux and a little bit of solder on the pads so it's easier to solder the components. Put there all the resistors, capacitors, all the SMD components. Don't forget to clean your PCB so it looks nice. And then also fit the headers. Okay, don't forget the jumper. And let's try it. So search for Arduino IDE. We need to download the Arduino software. I'm using Windows, so I'm going to download this. Once you download it, install it, it's like super easy. Then start the software, file, examples, blink. This is the simplest example what we can try. And we need to have a look where our user LED is connected. It's on pin 8. So I'm going to put here define user LED is on pin 8. I'm going to copy this and I'm going to put it here, here, and here. Okay, now let's connect our board. The green LED should go on. You can see some current is flowing into our board. Connect our board and upload the software or firmware. The red LED should start blinking. Yes. Okay. So user LED is working. Let's try something else. Let's try this temperature sensor. So go back to the Arduino, manage libraries, search for TMP75, install. We can use these libraries so we don't have to write everything from scratch. Go to examples, basic usage. So we need to put this code into our Arduino. I'm going to copy it and paste it here. I'm going to delete this, make it nicer, move this a little bit up. Okay, let's have a look what else we need. So I'm going to copy this. We need to initialize the serial communication. We would like to see the temperature in serial console. Also initialize the I2C. And now let's talk to our sensor and show the temperature in the console. Okay. I'm going to close this libraries panel, make this a little bit bigger. Now we can upload the new firmware and tools, serial monitor, let's see. Oh, cool. Be sure the baud rate is set correctly, okay? It needs to be what is in your setup, and you can see it shows the temperature. When I touch the sensor, the temperature is changing. Okay, you can see it here. Now we would like to try the MOSFET, so search for Arduino PWM. That's how we control the MOSFET. And here is example. So we need to specify the pin, then do some setup, and then use this. So I'm going to define our switch. It's connected to GPIO 6. So this is the PWM output from the Arduino board. I'm going to specify the output mode for this pin. Just copy this and put it here. And we have all this. Now we are going to use it. So this is how we set up the PWM output on the GPIO. And maybe I'm going to make it a little bit more complicated. I'm going to put this into a loop so we can see the PWM effect on this output. It's super simple. Just make this very simple loop, put it inside, and we would like to increase the, we would like to change the value of PWM inside of the loop. Put here some delay, and when everything is finished, then we would like to switch off the switch or turn off the switch. So I'm going to set this to 0. Okay, this should be enough to test the MOSFET switch. I'm going to use an LED, and also we need to connect the battery holder to our board. So make the connector, put the batteries in, connect the LED, connect the external power, and the LED should, the brightness of the LED should be changing. Watch the LED. See? So it's not like direct on off, but you can see it's from the darkest to the full LED. I'm going to connect motor. This is going to be more interesting because this is power switch. You can actually connect there any kind of load. Okay, it's working. The motor is slow, faster and faster and faster. Now we would like to test the servos. So search for Arduino servo. How do we control these servos? Let's have a look. Here's an example. So we need to put this inside of our code. I'm going to copy it, paste here. I'm going to move it, and we have 2 servos. So I'm going to call this my servo 1, make it nicer. And also we need to specify where the servo is connected. So servo 1 is controlled by GPIO D4. Put here 4. Now what next we need? In the setup we need to put there this code. So paste here, and it's connected to this GPIO, okay? And also this is the code which is actually controlling the servo. So I'm going to add this into the main loop. And we need to also use the correct name. So copy this, paste, paste, and the value, initial value is going to be 0. Delay, I will set this to 500. I'm going to copy this and paste it maybe 2 more times. Okay, and then here 30 degrees and 60 degrees. So this says how the servo is going to be rotated, how many degrees. Connect it correctly, okay? Be sure you plug in this cable correctly, plus minus and the input. Compile the code and let's see what will happen. Yeah, it works. Okay, so the LED is working, the MOSFET is working, and servo 1 is working, and also the temperature sensor is working. The last thing what we would like to try is the second servo. So I'm simply going to copy this, paste it, servo 2, double check where this is connected, D7. So put here 7. We need to define second servo. We need to initialize this. Okay, change to servo 2, and we can control the second servo in the main loop. So just do it exactly same way as the servo 1, just change this to servo 2. Again, don't forget, connect it correctly, okay? Black is minus, red is plus, and yellow is the control pin. Upload the software and watch what is going to happen with the second servo. Works. Cool. Perfect. And that's it. That's everything for this tutorial. I really hope you design and build your own board and it's working. If yes, fantastic job. Well done. Now, you know everything important to start designing your own project. If you would like to learn more about electronics, check out our online courses. You can find there courses about KiCad, Altium, Cadence. There are courses for beginners and also for professionals about designing boards, PCB layout, EMC testing, measuring, and more. Just go to fedevel.com. Please don't forget to leave your comments and let me know if you like this tutorial. Thank you very much for watching and see you next time. Bye.